Somewhere out there, beyond the soft glow of our nearest streetlight and past the faint shimmer of the moon, the universe stretches on forever. Stars burn in their billions. Galaxies spin in slow, silent spirals. And on countless worlds we will never see, perhaps at this very moment, other minds might be looking up at their own night sky, wondering the same thing we wonder. Are we alone? Is there anyone else out there? Brian Cox, the physicist with the gentle voice and the heart full of cosmic wonder, has spent a lifetime exploring this question, and his answer, delivered with the quiet sadness of someone who has truly understood what the numbers mean, might surprise you. It is not that aliens do not exist. The universe is simply too vast, too ancient, and too richly seeded with the ingredients of life for us to be the only ones. No, the problem is far stranger, far more heartbreaking, and far more final than that. The problem is that we can never meet them. Not never in the sense of unlikely. Not never in the sense of we just need better technology. Never in the truest, most absolute sense of the word. The laws of physics themselves, the very rules that govern every atom in your body and every photon of starlight that has ever touched your eyes, these laws have built a prison around us. A prison made of light. A prison made of time. A prison made of distances so impossibly vast that the human mind was never designed to comprehend them. And tonight, as you drift off to sleep, we are going to explore that prison together. We are going to understand, truly understand, why the stars will always remain just out of reach. And perhaps, in understanding that beautiful, terrible truth, we might come to appreciate just how precious and how rare this little blue world of ours truly is. If you find comfort in these cosmic journeys, if the vastness of space helps quiet your mind and ease you into peaceful dreams, please consider subscribing to this channel and leaving a like on this video. It helps more than you know, and it means we can keep exploring the universe together, one sleepy night at a time. Now, let us begin at the beginning. Let us start with the silence. Have you ever stood outside on a truly dark night, far from the city lights, and looked up? If you have, you know the feeling. It is almost overwhelming at first. The sky is not black at all. It is alive with light. Thousands of stars, maybe tens of thousands if your eyes are good and the air is clear, scattered across the darkness like diamonds on velvet. The Milky Way stretches overhead, a river of pale light that our ancestors once believed was the pathway to the afterlife. And in that moment, standing beneath all that ancient light, something shifts inside you. You feel small, yes, but you also feel connected. Connected to something vast and old and beautiful beyond words. But here is the thing that keeps physicists awake at night. The thing that has puzzled the greatest minds of our species for nearly a century. If the universe is so big, so old, so filled with stars and planets and all the raw materials of life, then where is everyone? Why, when we point our radio telescopes at the sky and listen with equipment sensitive enough to detect a cell phone signal from the other side of the solar system, do we hear nothing but static? Why, when we search the light of distant stars for the telltale chemical signatures of alien technology, do we find only natural processes? Why, in all our years of looking, have we never found a single, undeniable sign that another intelligent civilization exists? This question has a name. It is called the Fermi Paradox, named after Enrico Fermi, the brilliant Italian physicist who first posed it over lunch one day in 1950. The story goes that Fermi and his colleagues were discussing the possibility of alien life and interstellar travel when Fermi suddenly looked up and asked, with genuine confusion in his voice, "Where is everybody?" It is a simple question, but its implications are profound. Consider the numbers for a moment. Our galaxy, the Milky Way, contains somewhere between 200 billion and 400 billion stars. Current estimates suggest that roughly 1 in 5 of those stars has an Earth-like planet orbiting in the habitable zone, that Goldilocks region where water can exist as a liquid on the surface. That means there could be 40 billion potentially habitable worlds in our galaxy alone. And our galaxy is just one of at least 2 trillion galaxies in the observable universe. 2 trillion. If each of those galaxies has a similar number of habitable planets, we are looking at a number so large it defies comprehension. 80 sextillion. That is 8 followed by 22 zeros. Even if the odds of life arising on any given habitable planet are vanishingly small, even if intelligent life is 1 billion to 1 shot, the sheer number of opportunities means that the universe should be teeming with civilizations. Some of them should be millions of years older than us, maybe billions. They should have had time to spread across their entire galaxy, to build megastructures visible from across the cosmos, to fill the universe with radio signals and probes and all the unmistakable signs of technological life. And yet, when we look, we see nothing. When we listen, we hear nothing. The universe is silent. This is the paradox. This is the great mystery that haunts every astronomer who has ever turned their telescope toward the stars in hope. But Brian Cox offers an answer, and it is not a comforting one. The answer is not that aliens do not exist. The answer is that the universe is simply too big for signals to cross, too big for ships to traverse, too big for civilizations, no matter how advanced, to ever truly connect. We are not alone because there is no one else. We are alone because we are trapped by the speed of light, trapped by the vast emptiness between the stars, trapped by the simple, brutal mathematics of cosmic distance and cosmic time. To understand this, we need to talk about the speed of light. Light is fast, unimaginably, impossibly fast. In 1 second, a beam of light can circle the Earth more than 7 times. It can travel from here to the moon in about 1¼ seconds. It can cross the entire distance from Earth to the Sun in just over 8 minutes. In our everyday experience, light might as well be instantaneous. When you flip a switch, the room fills with light so quickly that your brain cannot even perceive the delay. When you look at a mountain on the horizon, the light entering your eyes left that mountain a few millionths of a second ago. For all practical purposes, you are seeing the present moment. But space is different. Space is so incomprehensibly vast that even light, traveling at the fastest speed possible in our universe, takes a long, long time to get anywhere interesting. Consider our nearest stellar neighbor, a dim red dwarf called Proxima Centauri. It is the closest star to our own sun, the very nearest point of light in our galactic neighborhood, and it is 4.24 light-years away. That sounds like a modest number, does it not? 4.24. You could count that high on your fingers. But let us unpack what it actually means. A light-year is the distance that light travels in 1 year. Light, moving at 300,000 kilometers per second, covers about 9.5 trillion kilometers in a single year. Trillion, 9.5 trillion kilometers, for 1 light year. Proxima Centauri is 4.24 of those, which means it is about 40 trillion kilometers away. 40 followed by 12 zeros. To put that in perspective, imagine you could drive to Proxima Centauri in a car, a nice, reliable car that can maintain a steady 100 kilometers per hour on the cosmic highway. How long would that drive take? The answer is about 45 million years. If you started driving when the dinosaurs went extinct, you would still have about 40 million years to go. Or imagine you could walk there. A brisk walking pace, say 5 kilometers per hour. At that speed, the journey would take roughly 900 million years. Almost 1 billion years of walking, one foot in front of the other, just to reach the nearest star. And Proxima Centauri is close. In cosmic terms, it is practically next door. It is like comparing the distance to your mailbox with the distance to the other side of the planet. Our galaxy, the Milky Way, is about 100,000 light years across. That means light, the fastest thing in the universe, takes 100,000 years to cross from one side of the galaxy to the other. If an alien civilization on the far side of the Milky Way sent us a radio message right now, traveling at the speed of light, we would not receive it for 100,000 years. And if we sent a reply, it would take another 100,000 years to reach them. A single back and forth exchange would span 200,000 years. For reference, 200,000 years ago, our ancestors had not yet developed language. They were anatomically human, yes, but behaviorally, they were still learning to be who we would eventually become. The entire history of human civilization, everything from the first cave paintings to the smartphone in your pocket, fits into a tiny fraction of that time. And the Milky Way is just one galaxy among trillions. The nearest major galaxy to our own, the Andromeda Galaxy, is about 2.5 million light years away. The farthest galaxies we can observe are over 13 billion light years distant. Their light has been traveling toward us since shortly after the Big Bang itself, and it is only just now reaching our telescopes. These are not just large numbers. They are incomprehensible numbers. Numbers that break the human brain. Numbers that make the entire concept of interstellar communication seem like a cruel joke played by a universe that wanted us to dream of the stars but never touch them. But wait, you might be thinking, surely we could at least send radio signals. Radio waves travel at the speed of light. We have been broadcasting them into space for over a century. Our television shows, our radio programs, our radar pulses, all of them have been radiating outward from Earth at 300,000 kilometers per second for decades. By now, a sphere of human radio signals roughly 200 light years in diameter surrounds our planet. This is true. And it is also true that we have been listening for similar signals from other civilizations. The SETI program, the search for extraterrestrial intelligence, has been pointing radio telescopes at the sky since the 1960s, hoping to catch a whisper, a hello, a mathematical sequence that could only have come from another mind. So far, nothing. But let us imagine, just for a moment, that tomorrow we receive a signal, a clear, unmistakable message from an alien civilization. It comes from a star 50 light years away, well within the range of our current detection capabilities. The message is a simple greeting, a mathematical proof, an invitation to respond. What happens next? We decode the message. We celebrate. It is the most important discovery in human history. We are not alone. The universe has other minds in it, and then we send a reply. We beam our response toward that distant star, pouring our hopes and our questions and our entire species into a focused beam of radio waves, and then we wait. We wait for 50 years for our message to reach them. Then we wait for them to compose a response. Then we wait another 50 years for that response to reach us. The minimum time for a single exchange of messages is 100 years, a century, an entire human lifetime. The scientists who send the first message will be dead before the reply arrives. Their children will be dead. Their grandchildren might live to see it, if they are lucky, and medical science advances enough to extend human lifespan. And this is for a civilization only 50 light years away, a cosmic stone's throw. If our correspondents are on the other side of the galaxy, we are looking at hundreds of thousands of years for a single conversation, millions of years for a meaningful dialogue, billions of years if they are in another galaxy entirely. This is not communication in any meaningful sense. This is archaeology. We would be exchanging artifacts with ghosts, receiving messages from civilizations that might have risen and fallen while their words were still crossing the void. And here is the darkest part of this cosmic truth. Even if alien civilizations exist right now, in abundance, all across the galaxy, we might never know. Not because they are hiding, not because they do not want to talk, but because the universe is so old and so vast that the timing never works out. Think about it this way. The universe is about 13.8 billion years old. The Earth has existed for 4.5 billion years. Life on Earth appeared about 4 billion years ago, but complex multicellular life only emerged around 500 million years ago. And humans, with our technology and our radio signals and our dreams of reaching the stars, we have been around for the blink of an eye. A few 100,000 years for our species, a few 100 years for our technology, a few decades for our ability to listen for alien signals. In the history of the universe, we are newborns. We have been capable of interstellar communication for roughly 100 years out of 13.8 billion years of cosmic history. Now imagine there is another civilization out there, on a planet orbiting a distant star. Maybe they arose 1 million years before us. In cosmic terms, 1 million years is nothing, a rounding error. A sneeze. But in practical terms, that 1 million years makes all the difference. If they developed radio technology 1 million years ago and broadcast signals into space, those signals passed by Earth long before we existed, long before there was anyone here to listen. Their hello came and went, and we were not around to hear it. Or maybe they arose 1 million years after us. In that case, we will be long gone before they begin to listen for signals. Our hello will pass by, their planet, when they are still in their Stone Age, or their equivalent of it. They will have no idea we were ever here. The window of opportunity for two civilizations to communicate is vanishingly small. Both have to develop the technology to send and receive signals at roughly the same time, in cosmic terms. Both have to survive long enough to maintain that technology. Both have to happen to be close enough that signals can cross the distance in a reasonable time frame. The odds of all these things lining up are astronomical, in the worst sense of that word. This is what Brian Cox means when he talks about the loneliness of the cosmos. It is not that the universe is empty. It is that the universe is full of islands, and every island is separated from every other island by oceans so vast and so treacherous that no ship can ever cross them. We are not alone in the sense that we are the only ones who exist. We are alone in the sense that we can never reach anyone else. We are alone in the only way that matters. But perhaps you are still holding on to hope. Perhaps you are thinking about faster than light travel, about wormholes and warp drives and all the wonderful technologies that science fiction has promised us. Surely, with enough ingenuity, with enough scientific advancement, we can find a way around the speed of light, a loophole in the laws of physics, a shortcut through the cosmic wilderness. This is where the news gets really hard, because the speed of light is not a speed limit in the way that a speed limit on a highway is a speed limit. You can break a traffic law. You can push your car past the posted maximum. You might get a ticket, but the physics of your car allows for it. The speed of light is different. The speed of light is not a rule that the universe chooses to enforce. The speed of light is a fundamental property of the fabric of reality itself. It is baked into the structure of space and time in a way that makes exceeding it not just difficult, not just impractical, but genuinely, physically, mathematically impossible. To understand why, we need to take a brief detour into the strange and beautiful world of Albert Einstein's special relativity. In 1905, Einstein published a paper that would change everything we thought we knew about space and time. He was only 26 years old, working as a patent clerk in Switzerland, scribbling equations in his spare time. And what he discovered was nothing less than revolutionary. Einstein realized that the speed of light is constant. Not constant in the sense of steady or unchanging, though it is both of those things. Constant in a deeper, stranger sense. The speed of light is the same for all observers, no matter how fast they are moving. This sounds simple, but it has absolutely mind-bending implications. Imagine you are standing on a train platform, and a train is moving past you at 100 kilometers per hour. Inside the train, someone throws a ball forward at 20 kilometers per hour relative to the train. From your perspective on the platform, how fast is the ball moving? Simple addition, right? 100 plus 20 equals 120 kilometers per hour. This is how we expect velocities to work. They add up. If something is moving and you throw something else from it, the speeds combine. But light does not work this way. If someone on that train shines a flashlight forward, the light does not move at the speed of light, plus 100 kilometers per hour. It moves at exactly the speed of light. The same speed of light you would measure if you were standing still. This is not just strange. This is impossible to reconcile with our everyday understanding of how motion works. And yet, it has been confirmed by experiment after experiment for over a century. Light always travels at exactly the same speed, no matter how fast you are moving when you measure it. Einstein accepted this bizarre fact and followed its logical consequences. And those consequences are astonishing. If the speed of light is constant for all observers, then something else has to give. That something else is time and space themselves. Einstein showed that as you move faster and faster, approaching the speed of light, time slows down for you. A clock on a speeding spacecraft ticks more slowly than a clock sitting still. This is not a mechanical effect. It is not that the clock breaks, or that its mechanisms are affected by motion. Time itself, the actual passage of moments, slows down. This effect is called time dilation, and it has been measured with extraordinary precision. If you put an atomic clock on an airplane and fly it around the world, when it lands, it will have lost a few billionths of a second compared to an identical clock that stayed on the ground. The GPS satellites orbiting Earth have to correct for time dilation, or your phone's navigation would be off by kilometers within a day. But here is the really strange part. As you approach the speed of light, time dilation increases. At 90% of the speed of light, your clock is running at about half speed compared to a stationary observer. At 99% of the speed of light, your clock is running at about 1/7 speed. At 99.9%, 1/22nd speed. And at the speed of light itself, at exactly the speed of light, time stops. A photon of light traveling through space experiences no time at all. From the photon's perspective, its journey is instantaneous. It is emitted and absorbed in the same moment, even if, from our perspective, it traveled for millions of years. This is already strange enough. But Einstein also discovered something even more problematic for any would-be interstellar traveler. As you accelerate toward the speed of light, you gain energy. The faster you go, the more energy you have. This energy contributes to your mass, not in the sense that you physically get heavier, but in the sense that it becomes harder and harder to accelerate you further. The energy required to make you go a little bit faster increases as you approach the speed of light. And here is the crux. To actually reach the speed of light, you would need infinite energy, not a lot of energy, not more energy than we currently have. Infinite energy, an amount of energy that cannot exist, cannot be produced, cannot even be meaningfully conceived of. The speed of light is not a wall you can break through with enough power. It is an asymptote, a limit that you can approach but never reach. The closer you get, the harder it becomes to get any closer. And actually touching that limit is forever beyond reach. This is not engineering. This is not a problem we will solve with better rockets or smarter scientists. This is mathematics. This is the fundamental structure of our universe. Nothing with mass can ever travel at the speed of light, period. And if we cannot reach the speed of light, we certainly cannot exceed it. But what about those science fiction standbys, wormholes and warp drives? Surely there must be some clever way around this limitation. Some loophole, some exception, some trick that advanced aliens might have discovered. The honest answer is probably not. And even if such things are theoretically possible, they come with problems so severe that they might as well be impossible. Wormholes are theoretical shortcuts through space-time. Imagine folding a piece of paper so that two distant points touch. Instead of walking the whole length of the paper, you could punch a hole through and step from one point to the other instantly. That is the basic idea of a wormhole. The problem is that wormholes, if they exist at all, would require exotic matter to keep them open. Exotic matter is a substance with negative energy density, something that has never been observed and may not be physically possible. Even if you could somehow create exotic matter, the amount required to stabilize a wormhole, large enough for a spacecraft, would be staggering. We are talking about the mass energy equivalent of Jupiter, converted entirely into this hypothetical substance. And even if you managed all that, wormholes might be unstable, collapsing the moment anything tried to pass through them. They might create paradoxes and causal loops that the universe simply does not allow. The more physicists study wormholes, the more impossible they seem. Warp drives are equally problematic. The basic idea of a warp drive is to compress space in front of your ship and expand it behind, creating a bubble in which the ship can move faster than light, without actually exceeding the local speed limit. It is clever, and it is mathematically consistent with general relativity. But it also requires, you guessed it, exotic matter. Lots of it, more than the entire mass energy of the observable universe in some calculations. And even if you could somehow gather that much exotic matter, the warp bubble would emit radiation so intense that it would vaporize anything in front of the ship when it dropped out of warp. Not exactly practical. The more we look for loopholes in the speed of light, the more the universe seems to close them. It is as if the cosmos was designed specifically to keep civilizations apart. As if the laws of physics were carefully calibrated to ensure that the stars would always remain beyond our grasp. Brian Cox puts it beautifully when he says that the universe is under no obligation to make sense to us. It is under no obligation to give us what we want. We wanted a universe full of neighbors, full of friends, full of fellow travelers on the cosmic journey. Instead, we got a universe of empty space and silence. But this is not the whole story. The speed of light is just the first barrier. Even if we could somehow travel at a significant fraction of the speed of light, even if we built generation ships that would carry thousands of humans on journeys lasting centuries, we would still face obstacles so severe that they might make interstellar travel practically impossible. Let us talk about the fuel problem. Rockets work by throwing stuff out the back. It is Newton's third law. Every action has an equal and opposite reaction. When you burn rocket fuel and exhaust it at high speed, the rocket is pushed forward. The more fuel you burn and the faster you exhaust it, the faster you go. The problem is that fuel has mass. The more fuel you carry, the heavier your rocket is. The heavier your rocket, the more fuel you need to accelerate it. This creates a vicious circle that rocket scientists call the tyranny of the rocket equation. Here is how bad it gets. To accelerate a small spacecraft to just 10% of the speed of light, using conventional chemical rockets, you would need a fuel mass so enormous that it defies comprehension. We are talking about fuel tanks larger than planets, fuel supplies that would take centuries to manufacture, engines that would have to burn continuously for years, and that is just to reach 10% of light speed. To get to a significant fraction that would make interstellar travel remotely practical, say 50% or higher, the numbers become truly absurd. You would need fuel masses larger than the Sun, larger than entire solar systems, larger than anything we could ever hope to produce. Nuclear propulsion helps some. Fusion engines, if we ever figure out how to build them, would be far more efficient than chemical rockets. But even fusion cannot escape the tyranny of the rocket equation. The numbers improve, but they do not improve enough. You still need fuel supplies beyond anything practical. Engines that can operate flawlessly for decades, spacecraft large enough to carry it all. Some scientists have proposed even more exotic propulsion systems. Antimatter engines, which would annihilate matter and antimatter together to produce pure energy. Laser sails, which would push spacecraft with giant beams of light from stations in our solar system. Bussard ramjets, which would scoop up interstellar hydrogen and fuse it as they go. Each of these has potential. Each of them also has severe problems that might prove insurmountable. Antimatter is the most efficient fuel possible, but we can only produce it in quantities measured in atoms. We would need tons of it. Laser sails work in theory, but we would need laser arrays more powerful than anything we have ever built, and there is no way to slow down at the destination. Bussard ramjets might not work at all, because the interstellar medium is even thinner than we once thought. The fuel problem is a reminder that the universe does not care about our dreams. It does not care that we want to explore. It does not care that we have imagined ourselves among the stars. The laws of physics apply equally to everyone, everywhere, and they are harsh. But fuel is not the only problem. There is also time. Even if we solved the fuel problem, even if we built spacecraft capable of reaching significant fractions of the speed of light, the journeys would still take decades or centuries from the perspective of those waiting back on Earth. Proxima Centauri, our nearest neighbor, is 4.24 light-years away. At 10% of the speed of light, the journey would take about 42 years. At 50%, about 8.5 years. At 90%, about 4.7 years. These sound almost manageable. But remember, we are talking about one-way trips. Any mission to Proxima Centauri would have to last at least twice as long if you want your astronauts to come home. And that is assuming everything goes perfectly. No breakdowns, no accidents, no unforeseen problems requiring a course change. And Proxima Centauri is the closest star. If we wanted to visit a star 50 light-years away, travel times would stretch into centuries even at near-light speeds. If we wanted to explore the far side of the galaxy, we would be talking about millennia. If we wanted to visit another galaxy, we would be talking about millions of years. No human being can live that long. No human society has ever remained stable and unified for more than a few centuries. How would we maintain a mission that lasts longer than recorded history? Who would greet the travelers when they arrived? Would human civilization even exist by the time they got back? These are not just engineering challenges. They are existential questions about what it means to be human and how we relate to time itself. Einstein's time dilation offers a partial solution. At very high speeds, time passes more slowly for the travelers than for those left behind. An astronaut traveling at 90% of the speed of light would age only about 4 years during a journey that took 10 years from Earth's perspective. At 99% of the speed of light, the ratio becomes even more extreme. In theory, you could travel to distant stars in what feels like months or years, while centuries or millennia pass on Earth. The travelers might arrive at their destination still young, ready to explore, full of hope for what they might find. But this creates its own problems. The astronauts would be leaving behind everyone they ever knew, their families, their friends, their entire world. By the time they arrived anywhere interesting, everyone who loved them would be dead. Civilizations would have risen and fallen. The Earth they remembered might no longer exist. They would be emigrants not just through space but through time. They would be stepping into the future and leaving the present behind forever. This is not travel in any ordinary sense. It is a kind of death, a permanent separation from everything familiar. And what would they find when they arrived? There is no guarantee that any destination would be habitable. Even Earth-like planets might have atmospheres we cannot breathe, ecosystems incompatible with our biology, or no life at all. The travelers might arrive to find a barren rock, or a world so alien that they could never make it home. Interstellar travel, even if possible, might be a one-way trip to nowhere, a final journey into the unknown with no hope of return and no certainty of a destination worth reaching. This is the reality that Brian Cox asks us to face, not the hopeful vision of Star Trek, with its warp drives and alien federations and casual interstellar commerce, not the adventure of science fiction, with its heroes zipping between stars like they are hopping between cities, but the cold, hard truth of physics and mathematics and the terrible, beautiful vastness of space. We are prisoners, not prisoners of our technology or our limited imagination, prisoners of the universe itself, locked in our tiny corner of the cosmos by bars made of light and time and the unforgiving emptiness between the stars. But perhaps you are still not convinced. Perhaps you are thinking that these are problems for our generation, but surely future generations will solve them. Surely, given enough time and enough progress, humanity will find a way. After all, our ancestors could not have imagined airplanes or rockets or satellites. Who are we to say what our descendants might achieve? This is a fair point, and it is one that scientists take seriously. But there are some barriers that no amount of progress can overcome, because they are not technological barriers at all. They are biological barriers, fundamental limitations on what living things can survive. Let us talk about radiation. Space is not empty. It looks empty to our eyes, but it is actually filled with a constant rain of high-energy particles. Cosmic rays, they are called, though they are not really rays at all. They are atomic nuclei, mostly protons and helium nuclei, stripped of their electrons and accelerated to incredible speeds by the magnetic fields of distant stars, supernovae, and the accretion disks around black holes. These particles are small, but they pack a tremendous punch. A single cosmic ray particle can carry as much energy as a baseball thrown by a professional pitcher, all concentrated in something smaller than an atom. When these particles hit you, they do not bounce off harmlessly. They tear through your body like bullets through tissue paper, smashing apart the molecules in their path. Here on Earth, we are protected from cosmic rays by two things: our atmosphere and our magnetic field. The atmosphere is like a thick blanket, absorbing most incoming particles before they reach the ground. The magnetic field is like an invisible shield, deflecting charged particles away from our planet. Together, they reduce the cosmic ray flux at sea level to a tiny fraction of what it is in open space. But in space, there is no atmosphere. And once you leave the protective embrace of Earth's magnetic field, there is no shield. You are exposed to the full fury of the cosmic bombardment. Astronauts on the International Space Station, orbiting just a few hundred kilometers above the Earth, still receive some protection from our magnetic field. Even so, they receive about 20 times the radiation dose of a person on the ground. Over a 6-month mission, they are exposed to roughly the same amount of radiation as getting 300 chest X-rays. This is manageable for short missions. The body can repair a lot of radiation damage, and the cancer risk for astronauts, while elevated, is not catastrophically high. But interstellar travel is not a short mission. We are talking about years or decades in space, far from any magnetic field, exposed to the full intensity of cosmic rays. The numbers are sobering. A human traveling to Mars, which takes about 7 months with current technology, would receive a radiation dose roughly equivalent to getting 1 full-body CT scan every week. Over the course of the journey, their cancer risk would increase significantly. Their risk of cataracts, heart disease, and neurological damage would also rise. And Mars is close, laughably close by interstellar standards. A few tens of millions of kilometers, less than a light minute at its nearest approach. An interstellar journey would last years or decades. The cumulative radiation exposure would be orders of magnitude higher. Without some form of protection, the travelers would almost certainly develop cancer. Their DNA would accumulate so much damage that their bodies might simply stop functioning correctly. They might age prematurely. They might lose cognitive function. They might die of radiation sickness before they ever reach their destination. Can we protect them? In theory, yes. You can shield against cosmic rays by surrounding yourself with mass. The more matter between you and the radiation, the more particles get absorbed before they reach you. This is why Earth's atmosphere works so well. It is equivalent to about 10 meters of water overhead. But mass is the enemy of space travel. Remember the rocket equation. Every kilogram of shielding you add is a kilogram that you have to accelerate to interstellar speeds. The fuel requirements grow exponentially. The engineering challenges become insurmountable. You could use water as shielding, doubling its purpose as radiation protection and drinking supply. But you would need enormous quantities, meters and meters of water surrounding the crew compartment. The spacecraft would balloon in size and mass. You could use magnetic shielding, creating an artificial magnetosphere around the ship, but the power requirements would be staggering. The magnetic field would have to be incredibly strong to deflect cosmic rays, and maintaining it for years or decades would require a continuous energy source. You could use clever designs, placing engines and fuel tanks between the crew and the direction of travel. Using the mass you are already carrying as a shield, this helps, but it does not solve the problem. Cosmic rays come from all directions. You cannot hide from them entirely. The truth is that we have no good solution to the radiation problem. Every approach we have considered either adds so much mass that the spacecraft becomes impractical, or requires so much power that we cannot sustain it, or provides only partial protection that might not be enough for the journey times involved. And cosmic rays are not the only radiation hazard. The Sun, and every other star, occasionally erupts with solar flares. These are sudden releases of energy that send waves of charged particles flooding through space. A major solar flare can deliver a lethal dose of radiation in hours. Astronauts caught outside during a flare without access to shelter would face a very real chance of death. In interstellar space, we would be exposed to similar flares from every star we passed, and we would have no way to predict them, no way to take shelter, no way to know when the next blast of radiation might come. This is the key reality of deep space. It is not the romantic void of science fiction, with its silent emptiness and serene beauty. It is a shooting gallery, a constant, invisible bombardment of particles that want to tear your cells apart. Life did not evolve to survive in space. We are creatures of planets, of atmospheres, of protective magnetic fields. Out there, in the darkness between the stars, we are fragile, exposed, and in constant danger. But let us set aside radiation for a moment. Let us imagine that we solved that problem somehow. Let us imagine perfect shielding, complete protection, no radiation exposure at all. Would that be enough to make interstellar travel practical? Unfortunately, no, because there are other biological problems that might be even harder to solve. Humans evolved on Earth. Our bodies are exquisitely adapted to this planet, to its gravity, its atmosphere, its day-night cycles, its temperature range, its nutrient availability. We are not general-purpose organisms capable of thriving in any environment. We are specialists, fine-tuned by billions of years of evolution for this one specific world. Take us off Earth, and things start to go wrong. Consider gravity. Every tissue in your body is designed to function under Earth's gravitational pull. Your bones have exactly the right density to support your weight. Your heart pumps blood with exactly the right pressure to overcome gravity's tendency to pull it in your legs. Your inner ear balances you against a constant downward force. In microgravity, all of these systems start to malfunction. Your bones begin to lose density because they are not being stressed. Your muscles atrophy because they are not working against gravity. Tism. Fluid accumulates in your head, causing headaches and vision problems. Your heart remodels itself, becoming less efficient because it does not have to work as hard. Astronauts on the space station exercise for 2 hours every day just to slow these effects. Even so, they lose bone density at a rate of about 1% per month. After a year in space, their bones are as fragile as those of a 70-year-old. It takes months or years after returning to Earth for them to recover. On an interstellar journey lasting decades, the cumulative effects would be devastating. Without constant exercise and careful medical management, the travelers might arrive at their destination unable to walk, unable to stand, their bones so weak that a minor fall could shatter them. We could solve this by spinning the spacecraft to create artificial gravity through centrifugal force. Banne. This is technically feasible, And many designs for interstellar ships include rotating sections for exactly this purpose. But it adds complexity, requires more mass and more engineering, and introduces new failure modes. What happens if the rotation mechanism breaks? What happens if the crew has to venture outside the spinning section for repairs? And gravity is just one issue. There are others that might be even harder to address. Consider the psychological effects of long-duration spaceflight. Human beings are social creatures. We evolved in small groups, surrounded by family and community, with constant interaction and stimulation. We need variety, novelty, social contact, and meaningful activity to maintain our mental health. An interstellar mission would be the opposite of all that. A small crew, maybe a dozen people at most, confined to a tiny spacecraft for years or decades. The same faces every day, the same rooms, the same views, the same routine repeated over and over until it loses all meaning. We have some experience with isolation studies here on Earth. In the most extreme cases, extended isolation leads to depression, anxiety, hallucinations, cognitive decline, and suicidal ideation. Even well-adjusted people, highly trained for the experience, struggle after months of confinement. Years would be something else entirely. The crew of an interstellar mission would have to maintain their sanity for longer than most relationships last, longer than most careers, longer than many human institutions. They would have to work together, without conflict or breakdown, for a journey that might span a significant fraction of their lifetimes. This is not just an engineering challenge. It is a challenge to the very nature of human psychology. And what about sleep? What about circadian rhythms? What about the countless biological processes that are key to Earth's 24-hour day-night cycle? In space, there is no sunrise and no sunset, no natural distinction between day and night. Astronauts on the space station see about 16 sunrises every 24 hours as they orbit the Earth, which wreaks havoc on their sleep patterns. On an interstellar journey, there would be no sunrises at all, just the constant, unchanging darkness of deep space. We could simulate day and night cycles with artificial lighting. Many spacecraft designs include this feature. But the human body is remarkably sensitive to light quality, timing, and intensity. Even small deviations from Earth's natural light patterns can disrupt sleep, mood, and cognitive function. Getting it exactly right, for years on end, is much harder than it sounds. Then there is the question of food. What do you eat on a journey lasting decades? You cannot bring enough food for a trip that long. The mass requirements would be prohibitive. 1. You would have to grow food on board, recycling nutrients and water in a closed-loop system that perfectly mimics the biosphere of Earth. This is the dream of bioregenerative life support. Scientists have been working on it for decades, and while we have made progress, we are nowhere near a system that could sustain a crew indefinitely without resupply. The problem is that ecosystems are incredibly complex. They involve thousands of species interacting in ways we do not fully understand. Trying to recreate a functional biosphere in a spacecraft is like trying to reproduce the Amazon rainforest in a shoebox. You inevitably miss something, and that something eventually causes the whole system to crash. The Biosphere 2 experiment in the 1990s was a famous example. Scientists sealed 8 people inside a giant greenhouse in the Arizona desert, intending them to live entirely on what they could grow inside. Within months, oxygen levels dropped dangerously low, crops failed, insects ran wild. The experiment had to be modified repeatedly just to keep the inhabitants alive, and even then it was considered a failure. space is far less forgiving than Arizona. There would be no option to open a door and let in fresh air. No option to resupply from outside. No margin for error at all. The life support system would have to work perfectly year after year, with no maintenance visits and no second chances. And we have not even discussed genetics. Cosmic radiation does not just damage your body. It damages your DNA. And while your cells have repair mechanisms that can fix most of this damage, those mechanisms are not perfect. Errors accumulate over time. Mutations build up. Cancer risk increases. But it gets worse. If your astronauts are going to establish a colony at their destination, they are presumably going to have children. Those children will inherit the accumulated genetic damage of their parents. Each generation will start with more mutations than the last. Over many generations, this genetic load could become unsustainable. Fertility might decline. Birth defects might increase. The colony might simply die out, unable to reproduce itself because its genome has degraded too far. This is not science fiction. This is basic genetics. Populations need to maintain a certain level of genetic integrity to survive long term. Space radiation erodes that integrity in ways that might be irreversible. Could we use genetic engineering to fix the damage? Perhaps, but we do not know how, not yet. And introducing genetic modification into a human population raises ethical questions that we have barely begun to address. Are we comfortable rewriting our own genome to survive in space? Would we even be human anymore if we did? These are the biological realities of interstellar travel. Not just engineering challenges, but fundamental conflicts between the nature of space and the nature of life. We evolved on this planet. We belong to this planet. Taking us away from it, subjecting us to the harsh environment of deep space, might be more than our biology can handle. Brian Cox understands this. He speaks of it with a kind of gentle sadness. The recognition that our dreams of the stars might always remain dreams. Not because we are not brave enough or smart enough, but because we are biological creatures living in a physical universe that was not designed with our survival in mind. But let us not stop there. Let us push further into the darkness and consider one more barrier to interstellar contact, perhaps the most troubling barrier of all: the Great Filter. The Fermi Paradox asks why we have not detected alien civilizations. We have discussed the difficulties of communication and travel across interstellar distances. But there is another possibility, one that is far more unsettling. What if civilizations do not survive long enough to make contact? What if there is something, some obstacle, some catastrophe that tends to destroy intelligent species before they can spread across the stars? What if the silence we observe is not because aliens are far away, but because they are dead? This is the concept of the Great Filter. Somewhere along the path from simple chemistry to interstellar civilization, there must be a step so difficult, so improbable, so dangerous, that almost nothing gets through. A filter that catches intelligent species and wipes them out before they can reach their full potential. The question is, where is the filter? Is it behind us, something we have already passed? Or is it ahead of us, something we have yet to face? If the filter is behind us, then we are incredibly lucky. We are one of the rare species that made it through. The universe is silent because the emergence of intelligent life is almost impossibly difficult, and we are among the very few who achieved it. This would be good news. It would mean that the hardest part is over. We have already beaten the odds. The future, while challenging, is ours to shape. But if the filter is ahead of us, then we are in trouble. It would mean that reaching our current level of development is relatively common, but that something awaits us that destroys almost all civilizations at our stage. Something we have not yet encountered, something that will probably kill us too. What could this filter be? Perhaps it is nuclear war. We have had the ability to destroy ourselves with nuclear weapons for nearly a century. We have come close to using them several times. Maybe most civilizations that develop nuclear technology eventually use it, wiping themselves out in the process. Perhaps it is climate change. A technological civilization requires energy. Energy production tends to alter planetary atmospheres. Maybe most civilizations fail to manage this transition, cooking their worlds into uninhabitability before they can escape to space. Perhaps it is artificial intelligence. We are rapidly developing machines that can think faster and more efficiently than we can. Maybe these machines, in most cases, decide that their creators are unnecessary. Or maybe they simply make decisions that optimize for their own values rather than ours, with catastrophic results. Perhaps it is biotechnology. We are learning to engineer viruses and bacteria with increasing precision. Maybe most civilizations eventually create a pathogen so deadly that it wipes them out before they can develop a cure. Or perhaps it is something we cannot even imagine yet. Some danger that lurks in our future, invisible to us now, but obvious in hindsight to any civilization that survives long enough to look back at our ruins. The great filter is speculative. We do not know if it exists or where it might be, but it fits the evidence. It explains the silence, and it should give us pause. If the universe is full of dead civilizations, destroyed by their own technology, or their own short-sightedness, or some inevitable catastrophe that accompanies intelligent life, then our future is not guaranteed. We might be racing toward the same cliff that every other species has tumbled over. We might be living in the brief window between capability and catastrophe, the moment before the filter catches us too. This is not a comfortable thought, but it is an honest one. And Brian Cox, for all his wonder at the beauty of the cosmos, does not shy away from it. He understands that the universe owes us nothing, that our survival is our own responsibility, that the silence of the stars might be a warning as much as a mystery. But there is another way to look at the great filter. Another interpretation that is no less sobering, but perhaps more applicable to our discussion of interstellar contact. What if the filter is not extinction? What if the filter is simply isolation? What if every civilization that reaches our level of development looks out at the stars and realizes what we are realizing now? That the distances are too vast, that the barriers are too high, that no matter how advanced they become, they will never travel to another star. They will never meet another intelligent species. They will live and die alone in their corner of the cosmos. Maybe every civilization reaches this understanding and makes peace with it. Or maybe they do not make peace with it. Maybe the realization drives them inward. Maybe they stop looking outward at all, turning their attention to their own world, their own concerns, their own local existence. This would explain the silence just as well as extinction would. The universe might be full of intelligent civilizations, but all of them have realized the truth. All of them have stopped broadcasting, stopped searching, stopped dreaming of the stars. They have accepted their isolation and moved on. This is not a tragedy of death. It is a tragedy of loneliness. A universe full of minds, separated forever by distances they can never cross, each one alone. Each one aware of the others perhaps, but unable to bridge the gap. A cosmic diaspora with no hope of reunion. Is this better than extinction? Is it worse? It is hard to say, but it is a possibility we must consider. The universe is big and old and strange. We are small and young and new. We have been looking at the stars for only an eye blink of cosmic time. We have been listening for signals for only a few decades. We have explored only a tiny fraction of the possibilities. Maybe the truth is something we have not imagined yet. Maybe the universe holds surprises that will overturn everything we think we know. But based on what we understand now, based on the physics and the biology and the mathematics of distance and time, the outlook for interstellar contact is bleak. Not impossible in some absolute sense, but impractical to a degree that might as well be impossible. The barriers are too high. The distances are too vast. The timescales are too long. The biology is too fragile. We are alone, not necessarily unique, but isolated, trapped on our little blue world by the laws of physics themselves. And perhaps that is okay. Perhaps being alone is not a curse, but a gift. Perhaps our isolation is not something to mourn, but something to cherish. Perhaps the very thing that seems to diminish us, our smallness and our solitude in this vast universe, is actually what makes us precious. Think about it. In all the cosmos, in all the billions of galaxies and trillions of stars and countless planets spinning through the void, here on this one world, life has taken root. Here, and perhaps nowhere else that we will ever know, matter has organized itself into something miraculous, something that can think, something that can feel, something that can look up at the night sky and wonder. We are the universe becoming aware of itself. We are atoms contemplating atoms. We are the cosmos grown curious about its own nature. This is not a small thing. This is not an accident to be dismissed. In a universe that is mostly empty space, mostly dead matter, mostly cold darkness stretching forever in all directions, we are an exception. We are a spark of something different. We are light and warmth and consciousness in an ocean of nothing. And because we cannot reach the stars, because we are confined to this one world for the foreseeable future, we have a responsibility to cherish what we have, a responsibility to protect this rare and precious thing that has emerged here against all odds in defiance of the void. The earth is not just our home, it is our only home, the only place in the universe where we know that beings like us can survive, the only island in an ocean that stretches beyond comprehension. When we pollute our air and our water, we are not just harming our environment. We are threatening the only refuge we have. When we drive species to extinction, we are not just losing biodiversity, we are diminishing the only garden that will ever exist for us. When we risk nuclear war or runaway climate change, we are not just endangering our civilization. We are gambling with the only consciousness we know exists. The stars will not save us. There is no escape hatch, no backup, planet, no cosmic lifeboat waiting to carry us away if we ruin this one. We are here, and here is all we have. This is the gift of isolation. It focuses the mind. It clarifies what matters. It strips away the illusion that we can afford to be careless with our world, because we can always find another. Brian Cox speaks of this with great feeling. He loves the cosmos. He has spent his life studying its wonders, marveling at its beauty, trying to understand its deepest secrets. But he also loves the Earth. He understands that our planet is special, not because it is unique in some abstract sense, but because it is the only place where his love can mean anything. The only place where human wonder can exist. The only stage on which the drama of our lives can unfold. The universe is magnificent, yes, but we cannot touch it. We can only look at it, study it, dream about it. And while we dream, we live here, on this rock, under this sky, in this moment. Let us not waste it. But wait, perhaps I'm being too pessimistic. Perhaps I'm giving up too easily on the dream of interstellar contact. After all, we have only been looking for a few decades. The universe is billions of years old. Maybe we just need to be patient. This is a reasonable objection, and it deserves a thoughtful response. It is true that our search for extraterrestrial intelligence is still in its infancy. The SETI program, despite its iconic status in popular culture, has explored only a tiny fraction of the possibilities. There are billions of stars in our galaxy alone, and we have listened carefully to only a handful of them. There are countless frequencies on which aliens might be broadcasting, and we have surveyed only a narrow slice of the spectrum. There are ways of communicating we might not even have imagined yet, technologies that could be operating right under our noses without us recognizing them. Maybe aliens are out there right now, beaming signals in our direction, using methods that our primitive technology cannot detect. Maybe they are waiting for us to develop the right equipment, the right sensitivity, the right understanding. Maybe the universe is full of conversation, and we just have not learned how to tune in yet. This is possible, and it is worth continuing to look. The search for extraterrestrial intelligence is one of the most profound questions we can ask, and even a negative result, even a universe that remains silent, tells us something important about our place in the cosmos. But we should be honest about what the search has revealed so far. We have been listening for over 60 years. We have surveyed millions of stars. We have detected nothing that even comes close to being a confirmed alien signal. Every candidate, every tantalizing blip, has either been explained by natural phenomena or remains unexplained but unrepeated. The silence is real. It is not a result of inadequate effort. It is not a result of insufficient patience. It is a genuine mystery that demands explanation. Maybe aliens are rare. Maybe intelligent life is a cosmic fluke, and we are among the very few examples in the observable universe. Maybe the Earth really is exceptional, and the emergence of minds like ours requires such a specific combination of circumstances that it almost never happens. This is called the rare Earth hypothesis, and it has gained significant support among scientists in recent years. The more we learn about the conditions necessary for life, the more we realize how many things had to go right for us to exist. The right kind of star, the right kind of planet, the right distance from the star, the right composition of the atmosphere, the right amount of water, the right mix of elements, a magnetic field to protect against radiation, a large moon to stabilize the axial tilt, a Jupiter-sized planet in the outer solar system to deflect asteroids, and on and on. Each of these factors is probably common enough on its own, but the probability of all of them occurring together on the same planet at the same time might be vanishingly small, small enough that habitable worlds like Earth are genuinely rare, small enough that intelligent life might be almost unique. If this is true, then the silence makes sense. The universe is not full of civilizations because the conditions for civilization are almost never met. We are not being avoided or ignored. We are simply alone. But there is another possibility that we should consider. Maybe aliens exist in abundance, but they are not communicating in ways we can detect. Maybe they gave up on radio technology long ago, moving on to methods that we cannot even conceive of. Maybe their signals are passing right through us, unnoticed, because we do not have the right equipment or the right concepts to recognize them. This is sometimes called the zoo hypothesis or the dark forest hypothesis, depending on how you frame it. Maybe aliens are watching us without revealing themselves, like scientists observing animals in a nature preserve. Or maybe they are hiding deliberately, afraid to announce their presence in a universe that might contain predators. These ideas are fascinating, and they make for great science fiction. But they are also unfalsifiable. If aliens are deliberately hiding, we will never find them no matter how hard we look. If they are using technologies beyond our comprehension, we will never detect them, no matter how sensitive our instruments become. These hypotheses explain everything and predict nothing. They are interesting to contemplate, but they do not really help us understand our situation. The most parsimonious explanation for the silence remains the one we have been exploring. The universe is vast. The distances are immense. The barriers to communication and travel are enormous. Even if aliens exist in abundance, we cannot reach them, and they cannot reach us. The silence is not a mystery to be solved. It is a feature of the cosmos itself. Let us take a moment to appreciate just how vast those distances really are. We have thrown around big numbers, light years, and trillions of kilometers. But big numbers can be hard to grasp. Let us try a different approach. Imagine that the sun is a grape, a small, round, yellowish grape sitting on a table in front of you. At this scale, the Earth is a tiny speck of dust about 15 meters away. You could fit 10,000 Earths inside the sun, but the Earth is still the place where all of human history has unfolded. All our wars, all our art, all our love, all our dreams, all of it happening on a mote of dust 15 meters from a grape. Where is the nearest star at this scale? Remember, Proxima Centauri is 4.24 light-years away. At the scale where the sun is a grape, Proxima Centauri is another grape about 400 kilometers away. That is roughly the distance from London to Edinburgh, or from Los Angeles to San Francisco. Think about that. You are standing at a table with a grape. The nearest other grape is 400 kilometers away, across cities and countryside and mountains and rivers. And between them, nothing. Empty space. Just those two little grapes, separated by hundreds of kilometers of void. Now zoom out. Our galaxy, the Milky Way, contains somewhere between 200 and 400 billion stars. At the grape scale, that would be 200 to 400 billion grapes, scattered across a volume so large that it would take millions of years to walk from one end to the other, even at this absurdly compressed scale. And beyond our galaxy, there are trillions more galaxies, each with their own hundreds of billions of grapes. Trillions of stars, separated by unimaginable gulfs of nothing. This is the universe we live in. A universe where the nearest neighbor is an impossible journey away. A universe where the very light that shows us these distant wonders takes years or centuries or millennia to reach us. A universe where everything is far and far means unreachable. When you truly understand this, when you let the reality of cosmic distances settle into your bones, the silence stops being mysterious. Of course we do not hear anything. Of course we do not see anything. The universe is just too big. The idea that we could casually communicate with beings on the other side of the galaxy is as absurd as expecting to have a conversation with someone on the other side of a grain field while shouting, except the grain field is billions of kilometers wide and you cannot even see the other person. The speed of light feels like a limitation, a frustrating cosmic speed limit that technology might someday overcome. But in reality, light is astonishingly fast. It is the fastest thing in the universe. Nothing can travel faster. And even at that impossible speed, Crossing the galaxy takes 100,000 years. We are not dealing with an engineering problem. We are dealing with the fundamental structure of reality. The universe is built in such a way that isolation is the default. Connection is the exception, the rare anomaly, the precious gift. And on the cosmic scale, connection might be impossible. But let us go deeper still. Let us consider not just the distances, but the timescales involved. We have talked about how long signals take to travel between stars. 4 years to Proxima Centauri. 100,000 years to cross the galaxy. Millions of years to reach another galaxy. These are communication times. Round-trip conversation times would be double that. But now consider the lifetime of a civilization. How long does a technological civilization last? We do not know because we only have one example, and our example is still running. Human civilization has existed for maybe 10,000 years if you count from the invention of agriculture. We have had radio technology for about 120 years. We have had nuclear weapons for about 80 years. We have had the internet for about 30 years. In the grand scheme of things, we are newborns. We have barely begun. The future stretches ahead of us, unknown and unknowable. But we are also fragile. We have the capability to destroy ourselves. Nuclear war could end our civilization in an afternoon. Runaway climate change could make the planet uninhabitable in a few centuries. A pandemic could collapse our society. An asteroid could wipe us out, as it wiped out the dinosaurs. We have power, but we are not invincible. How long will human civilization last? 1,000 years, 10,000, 1,000,000. Optimists hope for billions of years, but optimism does not change physics or probability. The historical record suggests that civilizations rise and fall on timescales of centuries to millennia. Nothing lasts forever. Now compare that to the timescales of interstellar communication. If an alien civilization arose 10 million years ago and lasted for 1,000,000 years, broadcasting signals into space the entire time, those signals would have passed by Earth long before humans existed. By the time we developed radio telescopes, their broadcasts would be ancient history, their civilization dust, their very existence a memory preserved only in the cosmic background radiation. The timing has to be just right. 2 civilizations have to exist at the same time, in cosmic terms. They have to be close enough that signals can cross the distance in a reasonable fraction of their lifetimes. They have to be technologically advanced enough to send and receive those signals. And they have to be looking in the right direction at the right moment. The probability of all these things lining up is tiny. Not zero, but tiny. And the universe is not required to stack the deck in our favor. We could search for 1,000,000 years and find nothing. Not because aliens do not exist, but because the timing never worked out. This is what makes the Fermi Paradox so poignant. It is not just about distance or technology. It is about time. We are not just separated from other civilizations by space. We are separated by time as well. Ships passing in the night, except the night is billions of years long and the ships are so small they might never see each other. Think about your own life for a moment. You exist in a particular window of time, a few decades if you are lucky, maybe a century if medicine advances far enough. During that window you are alive, conscious, experiencing the world. Before that window, you did not exist. After it, you will not exist. Your entire life is a brief flicker in the vastness of time. Now expand that to civilizations. A civilization exists for a certain window. Maybe thousands of years, maybe millions. During that window, it is alive, active, reaching out to the stars. Before and after, nothing. just the empty planet, the silent ruins, the universe continuing on without it. The universe is almost 14 billion years old. It will continue for trillions of years into the future, or perhaps forever, if certain theories are correct. Against that backdrop, even a civilization that lasts a billion years is a momentary thing, a flash, a spark that flares and fades. What are the odds that two sparks will flare at the same time, in the same part of the sky, close enough to see each other? In a universe this big, this old, this dark, the odds are not good. We might be screaming into the void not because no one is out there, but because everyone who is ever out there is already gone, or because everyone who will ever be out there has not yet arrived. We are alone in time as well as space. This is the deepest tragedy of our cosmic situation. The universe might be teeming with civilizations arising and flourishing and dying across the billions of years of cosmic history. Millions of species might have looked up at the stars and wondered if they were alone. Millions might have searched for signals and found only silence. Millions might have dreamed of contact and never achieved it. And all of them, separated by the immensity of time, never knew each other existed, never shared a thought or a word or a moment of connection. Ships passing in the night, forever. We are one of those ships. Right now, in this moment, we are alive. We are looking. We are hoping. And for all we know, a million other ships are doing the same thing, scattered across space and time. All of them alone. All of them wondering. But we will never know. The universe keeps its secrets. The distances are too great. The time scales too long. The barriers too high. We are born into isolation, and we will die in it. That is simply the nature of things. Is this depressing? Perhaps. But it can also be freeing, in a strange way. If we cannot reach the stars, then we do not have to feel guilty about not reaching them. We do not have to worry that we are falling behind some cosmic standard, that other civilizations are doing better than us, that we are failing some test of intelligence or ambition. We are not in competition with anyone. There is no race to win. There is only us here now, doing our best with what we have. If we cannot save ourselves by escaping to another planet, then we have to save ourselves here. We have to make this world work. We have to solve our problems, resolve our conflicts, build a sustainable civilization that can last. Not because the stars are watching, but because there is nowhere else to go. If the universe is indifferent to us, then we have to be kind to ourselves. We have to find meaning and purpose and joy in our own existence, without expecting the cosmos to validate us. We have to create our own significance, our own value, our own reasons for being. The universe will not do it for us. And if we are alone, truly alone, then every human connection is precious. Every friendship, every love, every moment of understanding between two minds. These are not common things. These are not cheap things. In a universe of isolation, they are miracles. Every conversation you have, every hand you hold, every shared laugh or cry or moment of silence. These are the rarest things in the cosmos. Treasure them. Brian Cox often speaks of the importance of perspective, of seeing ourselves clearly, without illusion, in our true context. We are small. We are brief. We are confined to a tiny speck of rock in an ocean of nothing. But we are also here. We are alive. We are aware. And for this one shining moment in the history of the universe, we get to experience existence. We get to ask questions and seek answers. We get to love and wonder and dream. That is not nothing. That is everything. Let us return to the practical barriers for a moment, because there are more details worth exploring. We have talked about the speed of light, about radiation, about fuel, about biology. But there are other challenges that make interstellar travel even more difficult than it might first appear. Consider the question of navigation. When you travel across a city, you can use landmarks, buildings, streets, signs, the position of the sun. When you travel across a country, you can use maps and GPS and the stars at night. But when you travel across interstellar space, what do you navigate by? The stars themselves move, not quickly by human standards, but over the time scales of an interstellar journey, their positions would shift noticeably. A trip to Proxima Centauri at 10% of the speed of light would take about 42 years. During that time, the stars would move slightly relative to each other. Your navigation charts, based on observations made at the start of the journey, would gradually become less accurate. For short journeys, this would not matter much. The stars do not move that fast. But for longer journeys, centuries or millennia, the cumulative drift would become significant. You would need to constantly update your position based on observations made during the voyage, correcting for the movement of everything around you. And what about obstacles? Space is mostly empty, but it is not perfectly empty. There are dust grains and small rocks, and chunks of ice scattered throughout the interstellar medium. At the speeds required for interstellar travel, even tiny objects become dangerous. A grain of sand, weighing a fraction of a gram, traveling at 10% of the speed of light, would hit with the energy of a small bomb. A pebble would be catastrophic. The kinetic energy scales with the square of the velocity, which means that high-speed collisions are exponentially more destructive than slow ones. We cannot see these small objects in advance. They are too small and too dark. We would be flying blind, hoping that the path ahead is clear, knowing that a single unlucky encounter could end the mission. Could we use shields? Yes, in principle. A thick layer of material in front of the spacecraft could absorb impacts from small debris. But this adds mass, which adds to the fuel requirements, which makes the whole enterprise even more impractical. Could we use active defenses, lasers to vaporize debris before it hits? Perhaps, but this requires detecting the debris in time to react, which is extremely difficult at high speeds. If you are traveling at 10% of the speed of light, you are covering about 30,000 kilometers every second. Even if you detected an obstacle 1,000,000 kilometers away, you would have only about 30 seconds to respond. That is not much time to identify the threat, aim your defensive system, and destroy or deflect it. The interstellar medium is less of a vacuum than you might think. It is thin, yes, unimaginably thin by earthly standards. But over the course of a journey spanning trillions of kilometers, you would encounter significant amounts of matter. Gas atoms, dust particles, ice crystals, all of them potential hazards at high speed. Some designs for interstellar spacecraft include magnetic fields or electric fields to deflect charged particles. This could help with some of the debris, but not all of it. Neutral atoms and dust grains would pass right through magnetic defenses. The faster you go, the worse this problem becomes. The energy of impacts increases. The time available to react decreases. The risk accumulates over the duration of the journey. What seems like empty space becomes a shooting gallery when you are moving fast enough. Then there is the question of communication with home. An interstellar mission would take years or decades at minimum. During that time, the crew would presumably want to stay in touch with Earth. They would want to send back observations, receive updated instructions, share their experiences with the people they left behind. But communication across interstellar distances faces the same constraints as everything else. radio signals travel at the speed of light. If your spacecraft is 4 light-years away, your messages take 4 years to reach Earth, and the reply takes another 4 years to reach you. An 8-year round trip for a single exchange. What happens when the spacecraft encounters an unexpected problem? A critical component fails. A crew member becomes seriously ill. The planned trajectory needs to be changed. In any of these situations, the crew would need advice and support from the experts back on Earth. But that advice would take years to arrive. By the time Earth learned about the problem, the situation might have resolved itself one way or another. By the time their recommendations reach the spacecraft, they might be completely irrelevant. An interstellar mission would have to be largely autonomous. The crew would have to solve problems on their own, make decisions without consultation, navigate crises without backup. This requires an extraordinary level of self-sufficiency and competence. It also means that the mission controllers on Earth would be spectators rather than participants. They could watch events unfold years after the fact, unable to intervene or help. They could send encouragement and support, but their messages would arrive long after they were relevant. This psychological burden should not be underestimated. The crew would be truly alone in a way that no human beings have ever been alone before. Not just physically isolated, but temporally isolated, cut off from the shared present of human civilization. Their lives would be happening in a different time, a different context, a different universe. And then there is the question of what happens when they arrive. Let us imagine, against all odds, that an interstellar mission succeeds. The spacecraft crosses the void, survives the radiation, dodges the debris, maintains its systems for decades, keeps its crew alive and sane. It arrives at Proxima Centauri or some other nearby star. What does it find? We know that Proxima Centauri has at least one planet, Proxima b, orbiting in the habitable zone. But we know almost nothing about what that planet is actually like. We cannot see it directly. We can only infer its existence from the tiny wobble it causes in its star and the slight dimming when it passes in front of the star from our perspective. Proxima b might have an atmosphere, or it might not. It might have liquid water, or it might be a frozen wasteland, or it might be a scorching hellscape, tidally locked with one side always facing its star. It might have life, or it might be utterly barren. We simply do not know. The travelers would be betting everything on a destination they cannot see. They would be committing to a journey of decades based on observations made from 4 light-years away. The planet that looked promising from Earth might turn out to be completely unsuitable for human life. And if it is unsuitable, if there is no atmosphere, no water, no way to survive, the travelers would have no way to return. They would have used all their fuel getting there. They would be stranded light years from home, on a world that cannot support them. This is not like exploring a new continent on Earth, where you can always turn back if things go badly. This is a one-way trip into the unknown, with no possibility of rescue, no margin for error, no second chances. The stakes could not be higher. Maybe robotic probes could scout ahead, sending back information about potential destinations before human missions are launched. This would help, but it would also take time. Sending a probe, waiting for it to arrive, waiting for its transmissions to reach Earth. We are talking about additional decades of delay, and the information from a probe would still be limited. A robot can take measurements and send data, but it cannot tell you what it feels like to stand on an alien world. It cannot tell you whether a place is truly habitable in the full, human sense of the word. Some things can only be discovered by being there. The exploration of other star systems, if it ever happens, will be an act of profound faith. Faith that the destination is worth the journey. Faith that the travelers will find what they are looking for. Faith that all the sacrifices and risks will somehow be justified in the end. And even if everything goes perfectly, even if the destination is everything they hoped for, the travelers will still be alone. They will be the only human beings within light years. Their colony, if they manage to establish one, will be cut off from Earth in every meaningful way. A separate branch of humanity, growing and developing in isolation, gradually becoming something different from the civilization they left behind. Is this colonization, or is it speciation? If humans spread to other star systems, if they adapt to different environments and lose contact with each other, will they remain one species, or will they diverge over millennia into distinct forms of intelligent life? Separate humanities, each unaware of the others, each thinking itself alone in the universe. This is the strange destiny that might await us if we ever do achieve interstellar travel. Not a grand galactic civilization, connected and unified, but a diaspora of isolated communities, separated by distances too vast to bridge, evolving independently for millions of years. The universe enforces loneliness at every scale. Even if we break out of our solar system, even if we seed colonies around distant stars, we will still be alone. Each colony will be alone. The human family will fragment and scatter, and eventually forget that it was ever one. But let us step back from these practical concerns and consider the bigger picture once more. Let us think about what all of this means. The universe is not hostile to life. That would imply intention, and the universe has no intention. The universe is simply indifferent. It does not care whether we exist or not. It does not care whether we thrive or perish. It does not care whether we ever meet another intelligent species. The laws of physics are what they are. The speed of light is what it is. The distances between stars are what they are. These facts were established in the first moments after the Big Bang, billions of years before life existed anywhere. They are not punishments or obstacles placed in our way. They are simply the rules of the game, the parameters of the reality we inhabit. We did not ask to be born into a universe like this. We did not choose the speed of light or the size of the cosmos. We are simply here, doing our best to understand our situation, trying to find meaning and purpose in circumstances we did not create. And there is meaning to be found. There is purpose to be discovered, but we have to create it ourselves. The universe will not hand it to us. The stars will not validate us. The aliens, if they exist, will not rescue us from our existential loneliness. We have to do the work ourselves. Brian Cox often talks about the importance of science as a source of meaning. Not the false meaning of supernatural beliefs, but the genuine meaning of understanding. When we learn how the universe works, when we grasp the laws that govern reality, when we see ourselves clearly in our cosmic context, we achieve something remarkable. We become, in a very real sense, the universe understanding itself. This is not a small achievement. In a cosmos dominated by dumb matter, by rocks and gas and dust that simply exist without knowing or caring, the emergence of minds that can ask questions and seek answers is miraculous. We are rare, we are precious, and our quest for knowledge is the highest expression of what we are. When we discover that the speed of light is a fundamental limit, we are not being defeated. We are learning something true about reality. When we realize that interstellar distances are effectively impassable, we are not being crushed. We are gaining wisdom. Knowledge is not depressing, even when it tells us things we do not want to hear. Knowledge is power. Knowledge is freedom. Knowledge is the only light we have in the darkness. And the darkness is real. Let us not pretend otherwise. The universe is mostly dark, mostly cold, mostly empty. Life is a tiny exception, clinging to the surfaces of a few rocky worlds, burning for a brief moment before fading back into the void. But that brief moment is ours. This instant, this here and now, this conversation between us in the middle of the cosmic night. This is what we have. This is what we are. And it is enough. It has to be enough, because it is all there is. Let us talk about something else now. Let us talk about the way our perception of time changes when we contemplate the cosmos. On a human scale, time moves quickly. Days pass, weeks pass, years pass. A decade feels like a long time. A century is beyond our direct experience. We can read about history, but we cannot feel it. The past is abstract to us, a story we tell ourselves about people who are no longer here. But cosmic time is different. Cosmic time stretches across billions of years, spans that dwarf everything in human experience. The Earth is 4.5 billion years old. The universe is nearly 14 billion years old. These numbers are so large that they become meaningless, just collections of digits that we cannot truly comprehend. And yet, these timescales are real. They are the context in which our lives unfold. We are part of a story that began long before us and will continue long after us. Our moment is infinitesimally brief compared to the age of the cosmos. This can be terrifying if you think about it wrong. The realization that you are a mayfly, a flash of consciousness in an eternal darkness, can trigger existential dread. Why does anything matter if it is all so brief? But it can also be liberating if you think about it right. The brevity of our lives is what gives them meaning. The scarcity of time is what makes time valuable. If we lived forever, nothing would be urgent, nothing would be precious, nothing would matter. It is precisely because our time is limited that we must use it wisely, must cherish each moment, must make our brief existence count. The same logic applies to our situation in space. The vastness of the cosmos, the impossibility of reaching the stars, the certainty of our isolation. These facts, which seem so crushing at first, actually serve to focus our attention on what matters. They strip away distractions and illusions. They force us to confront reality as it is, not as we wish it were. And reality, confronted honestly, is not depressing. It is awe-inspiring. The universe is staggeringly beautiful, even if we can only see a tiny fraction of it. The laws of physics are elegant and profound, even if they impose limitations we cannot overcome. Life is miraculous, even if it is rare and fragile and brief. We are witnesses to something incredible. We are participants in a drama that spans billions of years and trillions of light years. We may be small, but we are here. We may be brief, but we are now. We may be alone, but we are aware. That awareness is everything. It is the one thing that separates us from the rocks and the gas and the empty space that makes up most of the universe. We know we exist. We wonder about our situation. We ask questions that the cosmos itself cannot ask. In a very real sense, we are the eyes and ears and mind of the universe. We are the way the cosmos experiences itself. Without us, without beings like us, the universe would simply be. It would have no one to appreciate its beauty, no one to understand its laws, no one to marvel at its vastness. Is this a responsibility? Perhaps. The only known minds in the cosmos, the only witnesses to the great drama of existence. if we destroy ourselves, if we squander this precious gift of awareness, who will be left to look up at the stars and wonder? Maybe no one. Maybe we are it. Maybe this brief flash of consciousness on this tiny world is all there will ever be. And when we are gone, the universe will continue on in silence, magnificent and meaningless forever. That thought should give us pause. It should make us careful. It should make us take seriously our responsibility to survive, to thrive, to preserve this rare and precious thing that we are. But let us not get too heavy. Let us return to the gentle wonder that is the heart of this journey. Picture yourself, for a moment, floating in space, not in a spacecraft, but somehow safe and warm, drifting among the stars. You look around and see the Milky Way stretching across the sky, a river of light made of billions of suns. You see distant galaxies, fuzzy patches of light that are themselves made of billions more suns, each with their own planets, their own possibilities. You are impossibly small, a mote of dust in an ocean of light, and yet you are here, seeing this, feeling this, being this. The universe is inside you as much as you are inside it. The atoms in your body were forged in the hearts of stars that died billions of years ago. You are made of stardust, literally, and the stardust is looking back at itself. This is the mystery. This is the wonder. This is what it means to be human in a universe like this. We cannot reach the stars, no, but the stars are already part of us. We cannot communicate with aliens, perhaps, but we can communicate with each other, and that communication is no less miraculous for being local. We cannot escape our isolation, true, but within that isolation, we have created love and art and music and science and everything that makes human life worth living. The universe gave us strict limits. Within those limits, we have built worlds of meaning. The universe gave us a finite lifespan. Within that lifespan, we have created moments of infinite depth. The universe gave us loneliness. Within that loneliness, we have found each other. Brian Cox would approve of this perspective, I think. He is a romantic, underneath all the physics. He loves the universe not despite its indifference, but because of it. The cosmos does not owe us meaning, and yet we find meaning anyway. The stars do not care about us, and yet we care about them. There is something noble in that, something defiant, something beautiful. We are the species that refuses to accept meaninglessness, even when confronted with a universe that offers no inherent meaning. We are the species that creates beauty even in the face of oblivion. We are the species that loves even though love cannot last forever. This is what we are. This is what we do. And no amount of cosmic indifference can take that away from us. Let us consider one more aspect of our cosmic situation. Let us think about what it would actually mean to make contact with another civilization. In science fiction, first contact is usually a dramatic moment. Spaceships arrive. Messages are exchanged. Sometimes there is conflict, sometimes cooperation. But either way, the encounter changes everything. Humanity is no longer alone. The universe suddenly has meaning and purpose and other minds to share it with. But if contact were actually possible, what would it be like? Imagine we received a signal from a civilization 500 light years away. The signal is unmistakably artificial. It contains mathematical sequences that prove it came from an intelligent source. It even includes images and sounds and some form of language that we might eventually learn to decode. This would be the most important discovery in human history. No question. The implications would be profound. We would know, finally and definitively, that we are not alone in the universe. The question that has haunted humanity since we first looked up at the stars would be answered. But then what? The civilization that sent the signal is 500 light years away. Their message took 500 years to reach us. Whatever they wanted to tell us, they thought of it 500 years ago. Half a millennium. Before Columbus sailed to America. Before the Renaissance. Before Shakespeare. Before Newton. Before the French Revolution. Before the Industrial Revolution. Before everything we think of as the modern world. The beings who sent that message might not exist anymore. Their civilization might have risen and fallen while their words were still crossing the void. By the time we hear them, they could be ancient history, as remote from their present as the Roman Empire is from ours. And if we send a reply, 500 years for our message to reach them. 500 years for their response to return. 1,000 years for a single exchange of thoughts. 40 generations of humans living and dying between one question and its answer. This is not communication in any meaningful sense. This is archaeology. We would be receiving artifacts from the past and sending artifacts to the future. We might learn things about them, yes. We might decode their language, understand their biology, glimpse their culture. But we would never know them. We would never have a conversation. We would never share a moment of connection across the stars. And they would never know us either. They would receive our reply 1,000 years from now. By then, human civilization might be utterly transformed. The beings who sent the original message might not even recognize us as the same species that received their transmission. We would be strangers to each other across time as well as space. Is this contact? In the strictest technical sense, yes. Information would have been exchanged. The universe would no longer be completely silent. But emotionally, spiritually, practically, it would still feel like isolation. We would know that someone else existed, but we would never meet them, never talk to them, never share anything real with them. The philosopher Thomas Nagel once wrote a famous essay called "What is it like to be a bat?" He argued that even if we knew everything about bat biology, we could never truly understand what it feels like to be a bat, to experience the world through echolocation, to navigate by sound in ways that humans cannot even imagine. The same problem would apply to alien contact, except far more extreme. Even if we decoded every detail of an alien civilization's messages, we might never understand what it is like to be them. Their minds might be so different from ours, their experiences so alien, their concepts so unfamiliar, that true understanding is impossible. We share a common biology with every creature on Earth. We are all made of the same basic molecules, shaped by the same evolutionary processes, descended from the same ancestors. Even with this common heritage, we struggle to understand each other. Humans have difficulty understanding other humans. The gap between cultures, between individuals, between minds, is vast. Now imagine trying to understand a being that evolved on a completely different world, under completely different conditions, with a completely different biology. A being that might not even have the same senses we do. A being that might perceive time differently, or space differently, or causality differently. A being whose very concept of self might be utterly unlike our own. Would we have anything to say to each other? Would our thoughts even translate? Or would we be like ships signaling across a fog, knowing the other is there, but never quite connecting? The optimist says that mathematics is universal, that the laws of physics are the same everywhere, that intelligent beings, no matter how different, would share certain fundamental concepts that could serve as a basis for communication. This might be true. The number 2 is probably the same whether you have hands or tentacles or something we cannot imagine. The relationship between a circle's diameter and circumference is probably the same on every world. Gravity follows the same equations around alien suns as it does around ours. But so what? Even if we could exchange mathematical truths, that would be the easy part. The hard part is everything else. The meaning and purpose and feeling that make communication worthwhile. The shared experience that turns information into understanding. I can tell you that 2 + 2 = 4, and you will agree. But I can also tell you that I am afraid of death, that I love my family, that sunsets make me feel peaceful, and certain pieces of music bring tears to my eyes. These are not mathematical truths. They are human truths, and I do not know if they would translate. Maybe they would. Maybe consciousness, wherever it arises, has certain common features. Maybe the experience of being aware, of having a self, of navigating a world full of dangers and opportunities, is universal enough that any mind would recognize it in any other mind. But maybe not. Maybe consciousness is more variable than we imagine. Maybe alien minds are so different from ours that they do not experience fear or love or peace or sadness. Maybe they do not have selves in the way we do. Maybe they are hive minds or distributed intelligences or something we have no concept for at all. The universe is creative. It has produced an astonishing variety of life here on Earth, from bacteria to blue whales, from fungi to flowering plants, from insects to intelligent apes. If life exists elsewhere, there is no reason to think it would look anything like what we know. The possibilities are literally infinite, and intelligence, if it exists elsewhere, might be equally varied. We have one example of technological civilization, ourselves. We tend to assume that any other such civilization would be recognizably similar, would have curiosity, would build tools, would want to explore, would seek to communicate. But these might be human traits, not universal traits. Other minds might have completely different motivations, completely different values, completely different ways of being. Contact with aliens, even if possible, might be deeply alienating. We might learn that we are not alone, but feel more alone than ever. We might discover that the universe contains other minds, but that those minds are so foreign that we can never truly connect with them. This is not necessarily a tragedy. Difference is interesting. The discovery of alien intelligence, however strange, would still be profound. It would still change our understanding of our place in the cosmos. It would still answer the question that has haunted us for millennia, but it might not give us what we really want, which is companionship, which is the feeling that someone out there understands us, shares our experiences, knows what it is like to be us. That kind of connection might be impossible across the gulf of space and biology and evolution that separates different intelligent species. We might be doomed to a kind of cosmic loneliness, even in a universe full of life, surrounded by minds we cannot fathom, receiving signals we cannot truly comprehend, knowing that others exist, but never really knowing them. This is perhaps the cruelest possibility of all. Not an empty universe, but a full one that still feels empty. Not solitude, but isolation even in a crowd. A cosmos teeming with consciousness that remains forever alone. But let us not dwell on cruelty. Let us return to wonder. Because here is the thing. All of this speculation, all of this reasoning, all of this careful analysis of the barriers to contact and the nature of communication and the limits of understanding, all of it is just thinking, just wondering, just asking questions and exploring possibilities. And that, in itself, is remarkable. We are creatures who can think about things that do not exist. We can imagine alien civilizations we have never met. We can ponder the nature of consciousness that might be different from our own. We can feel loneliness for connections that might be impossible. No other species on Earth does this. No other creature looks up at the stars and wonders if someone is looking back. No other being contemplates the possibility of contact with intelligences beyond their world. This capacity for abstract thought, for imagination, for reaching beyond the immediate and the concrete. This is uniquely human, and it is wonderful, not in the happy, cheerful sense, but in the original sense of the word, full of wonder, awe-inspiring, mysterious and profound. We are small, yes. We are brief, yes. We are isolated, yes. But we are also dreamers. We are also questioners. We are also seekers of understanding in a universe that does not offer understanding easily. That seeking is what makes us human. That refusal to accept ignorance, that drive to know more, that willingness to look into the darkness and ask what is there. It connects us to every scientist who has ever peered through a telescope, every philosopher who has ever pondered existence, every child who has ever asked why. The questions matter even if we never find the answers. The seeking matters even if we never reach the goal. The wondering matters even if the wonder is never resolved. Brian Cox embodies this spirit. He has spent his life asking questions about the universe, knowing that he will never answer all of them, knowing that the cosmos is far too vast and complex for any one mind or any one species to comprehend. And yet he keeps asking. He keeps exploring. He keeps sharing what he has learned with anyone who will listen. This is the scientific impulse at its purest, not the quest for certainty, but the embrace of mystery, not the conquest of nature, but the appreciation of its depths, not the triumph of human cleverness, but the humility of recognizing how much we do not know. We will never contact aliens. Probably, almost certainly. The barriers are too high, the distance is too great, the timing too improbable. We will live and die without ever knowing for sure whether other minds exist in the universe. But we can wonder, we can imagine, we can dream, and in doing so, we can experience a kind of contact that is purely internal, purely human, purely our own. A contact with the idea of alien intelligence, even if not with the reality. Is this a consolation? Perhaps a small one. We wanted companions and got only ourselves. We wanted answers and got only questions. We wanted the stars and got only the Earth. But the Earth is something. The questions are something. We are something. In a universe that might be mostly nothing, something is not a small achievement. So let us rest here for a moment. Let us float in the darkness between the stars, metaphorically, imaginatively, in the safety of our own minds. Let us feel the vastness around us, the emptiness, the silence. Let us acknowledge what we cannot have, and then let us return to what we do have. This planet, this moment, this consciousness, this breath right now, filling your lungs with oxygen that was released by plants that grew in sunlight that traveled 93 million miles from a star that has been burning for 4.5 billion years. You are connected to the cosmos in ways that do not require interstellar travel. You are made of cosmic material. You are part of the cosmic story. The universe is not something out there separate from you. The universe is you. You are it. There is no separation. The loneliness we feel when we look up at the stars is real. The impossibility of contact with other civilizations is real. But the connection we have with the universe itself is also real. We are not visitors here. We are not strangers passing through. We belong to this cosmos as much as any star or galaxy or nebula. And in belonging, there is peace. In understanding our true situation, there is acceptance. In accepting what we cannot change, there is freedom to focus on what we can. We can take care of this planet, the only home we will ever have. We can cherish each other, the only companions we can be sure of. We can pursue knowledge and wisdom and beauty and love, the only things that give life meaning. The stars will remain out of reach. The aliens, if they exist, will remain forever silent to us. The cosmic distances will not shrink. The laws of physics will not change. But we can change. We can grow. We can learn. We can become better, wiser, kinder, more aware. We can make our brief moment in the sun count for something. And that is not nothing. That is everything. As we drift toward the end of this cosmic journey together, let us pause to gather what we have learned. The universe is vast beyond comprehension. Distances that seem like reasonable numbers on a page, 4 light years, 50 light years, 100,000 light years, represent gulfs of emptiness that no spacecraft can cross, no signal can meaningfully traverse, no connection can bridge. We are separated from the stars not by miles or kilometers, but by the fundamental structure of space and time itself. The speed of light, that cosmic constant that governs all of reality, is both incredibly fast and hopelessly slow. Fast enough to circle the Earth 7 times in a second, but slow enough that messages to even the nearest star take years to arrive. And nothing can exceed it. Not technology, not ingenuity, not the desperate longing of a species that wants to reach out and touch the infinite. The barriers to interstellar travel are not just engineering challenges. They are fundamental incompatibilities between the nature of life and the nature of space. Radiation that tears through living tissue. Gravity that our bodies cannot do without. Timescales that exceed the lifespan of individuals, societies, perhaps entire species. The fuel requirements that mock our most powerful rockets. The distances that laugh at our grandest ambitions. Even communication, that most basic form of contact, is crippled by the realities of cosmic distance. A conversation with beings 50 light years away would span a century for a single exchange. A dialogue with the other side of the galaxy would take longer than recorded human history. We could shout into the void and never hear an answer, or hear an answer so delayed that we no longer remember the question. The great filter, whatever it is, looms over every technological civilization. Whether it lies behind us or ahead of us, it suggests that the path from simple life to starfaring civilization is strewn with obstacles. Many species, perhaps most, never make it. The universe might be littered with the ruins of civilizations that rose and fell, each one thinking they were special, each one ultimately humbled by the realities they could not overcome. And even if other civilizations exist, even if they are out there right now looking at the stars and wondering if they are alone, the odds of making contact are vanishingly small. The timing has to be perfect. 2 civilizations arising at roughly the same cosmic moment, close enough to exchange signals in a reasonable time, both looking in the right direction at the right frequency with the right technology. In a universe that spans billions of years and trillions of light years, the odds of this alignment are astronomical. We are alone. Perhaps not unique, but alone. isolated on our little world by distances we cannot cross and timescales we cannot bridge. The stars that seemed so inviting when we first looked up at them turn out to be unreachable. Each one a sun, perhaps warming planets of its own, but forever beyond our grasp. This is the truth that Brian Cox asks us to accept, not with despair, but with understanding, not with resentment, but with wisdom. The universe is what it is. Wishing it were different does not make it so. And there is a kind of peace in accepting reality, even when reality is not what we hoped. But acceptance is not the end of the story, because within this acceptance, within this recognition of our cosmic isolation, lies something precious, something that transforms the tragedy into triumph, something that turns loneliness into a kind of grace. We are here. Against all odds, against all the barriers and filters and impossible improbabilities, life emerged on this planet. Not just life, but conscious life. Not just conscious life, but intelligent life. Not just intelligent life, but a species capable of asking questions about its own existence, capable of looking up at the stars and wondering, capable of building telescopes and spacecraft and radio dishes to search for others like itself. The very fact that we can contemplate our loneliness is remarkable. The atoms that make up your brain were forged in the nuclear furnaces of stars that burned out billions of years ago. Those atoms somehow assembled themselves into molecules, and those molecules somehow assembled themselves into cells, and those cells somehow assembled themselves into a being that can feel sad about not having alien friends. Do you see how extraordinary that is? The universe has produced in us something that can understand itself, something that can ask why, something that can feel the weight of cosmic solitude and transform that feeling into poetry and science and philosophy and love. We are not just observers of the universe. We are the universe observing itself. We are not just inhabitants of the cosmos. We are the cosmos becoming aware. In us, matter has achieved something miraculous. It has begun to think. It has begun to wonder. It has begun to care. No alien signal could be more remarkable than this. No contact with another civilization could be more profound than the contact we have with ourselves, with each other, with the universe that gave rise to us. We are already participating in the greatest miracle imaginable. We are already connected to the cosmos in the deepest possible way. The loneliness we feel when we look at the stars is real, but it is not the whole story. Beneath that loneliness is something more fundamental, a belonging that no distance can diminish, a connection that no isolation can break. You are made of star stuff. This is not poetry. This is physics. Every atom heavier than hydrogen in your body was created in the heart of a star or in the violent explosion of a supernova. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was cooked up in stellar furnaces and scattered across space in cosmic cataclysms. You are not separate from the universe. You are the universe, a particular temporary conscious configuration of universe. When you look at the stars, you are looking at your ancestors. When you feel the warmth of the sun, you are feeling the same nuclear processes that created the elements in your body. When you breathe, you are participating in cycles of matter and energy that connect you to every corner of the cosmos. This connection is not metaphorical. It is literal. It is physical. It is as real as the ground beneath your feet and the air in your lungs. You belong here. You are part of this. You are home. And if you are home, then you are not truly alone. You are surrounded by fellow travelers on this cosmic journey. Billions of other humans, each one made of the same star stuff. Each one conscious and wondering and seeking. You share this moment with all of them. You share this planet, this solar system, this galaxy, this universe. You are all in this together. Beyond humanity, you share the Earth with millions of other species. Life in all its forms, from the bacteria in your gut to the whales in the ocean, from the birds in the sky to the trees in the forest. All of it related to you. All of it descended from the same ancient ancestors. All of it participating in the same grand experiment of existence. You are not alone. You are part of a community that spans the globe, that reaches back billions of years, that extends to the very stars themselves. The loneliness you feel when you contemplate the empty spaces between the stars is an illusion created by thinking too small. Think bigger. Think of everything you are connected to. Think of everyone who shares this moment with you. Now let your eyes close, if they are not already closed. Let your breathing slow. Let the tension drain from your shoulders and your jaw and your hands. Let yourself relax into this moment, this here, this now. The universe is vast and dark and mostly empty. But you are not in the vast, dark, empty parts. You are here, on a world teeming with life, in a body that works miraculously without your conscious intervention, surrounded by air to breathe and water to drink and food to eat. You are in the warm, bright, living parts of the universe. You are in the good parts. The stars will remain distant. The aliens, if they exist, will remain silent. The great cosmic questions will remain unanswered, at least in your lifetime, at least in your species' lifetime. But that is okay. Not every question needs an answer. Not every mystery needs a solution. Sometimes the wondering itself is enough. Brian Cox once said that the universe is under no obligation to make sense to us. He is right. But here is the beautiful thing. It does make sense, some of it, some of the time. We have figured out how stars burn and how galaxies form and how life evolves. We have decoded the laws of physics and traced the history of the cosmos back to the first moments after the Big Bang. We have done this with brains made of meat, using tools made of metal, living on a planet made of rock, spinning through a universe made of mystery. That is an achievement beyond anything the universe could have expected of us. It expected nothing, of course. It has no expectations. But if it did, we have exceeded them. We have become more than the cosmos had any right to hope for, and we are still going. Still learning, still growing, still reaching toward understanding, even when understanding seems impossible. This is who we are. This is what we do. We do not give up. We do not accept ignorance as our final state. We keep pushing, keep asking, keep searching, even when the answers refuse to come. The search for extraterrestrial intelligence will continue. Radio telescopes will keep scanning the skies. New technologies will emerge that let us look further and listen more carefully. Maybe someday, against all the odds I have outlined tonight, we will detect a signal. Maybe someday we will know for certain that we are not alone. But even if we never do, even if the search goes on forever without success, it will still have been worth it. Because the search is not just about finding aliens. It is about understanding ourselves. It is about taking our place in the cosmos with open eyes and curious minds. It is about being the kind of species that asks big questions, even when the answers are daunting. We are seekers. We are dreamers. We are wanderers. These qualities define us as much as our biology or our history. They are what make us human. They are what make us beautiful. So rest now, weary traveler. Let the vastness of space be not a burden, but a blanket, wrapping around you soft and dark and peaceful. Let the silence of the cosmos be not a rebuke, but a lullaby, singing you toward sleep with its ancient stillness. Let the loneliness of the stars be not a sorrow, but a reminder of how precious company is, how valuable connection, how miraculous every moment of shared existence. You have traveled far tonight. From the earth to the stars, from physics to philosophy, from despair to acceptance to wonder. You have contemplated distances that dwarf imagination and time scales that humble ambition. You have looked into the darkness and seen it clearly, without flinching, without turning away. And you have found, I hope, something worth holding on to. A perspective that acknowledges the difficulty of our situation without being crushed by it. An understanding that sees both the barriers and the beauty. A wisdom that accepts what cannot be changed and cherishes what can. The stars are not ours. The galaxy is not ours. The universe is not ours. We cannot claim them or conquer them or make them bend to our will. They are too big, too far, too indifferent to our desires. But this moment is ours. This breath is ours. This awareness, this wondering, this gentle sinking towards sleep, this is ours. No cosmic distance can take it from us. No alien silence can diminish it. No physical law can prevent us from experiencing it fully. Right here, right now, you are alive. You are aware. You are part of something ancient and vast and beautiful beyond words. Whatever tomorrow brings, whatever the future holds, whatever answers we eventually find or fail to find, this remains true. This is your birthright as a conscious being. This is your inheritance as a child of the stars. Rest now. Dream of distant galaxies and impossible journeys and civilizations rising and falling across the eons. Dream of questions without answers and wonders without end. Dream of a universe that does not need us but somehow produced us anyway, against all odds, in defiance of all probability. And when you wake, carry a little of this cosmic perspective with you into your day. Remember that you are rare and precious and brief. Remember that every connection you make is a miracle. Remember that the stars, for all their beauty, are just light, and light cannot think or feel or love. But you can. You do. That is the gift. That is the consolation. That is the truth that makes everything else bearable. We cannot reach the stars, but we can appreciate them from here. We cannot speak to aliens, but we can speak to each other. We cannot escape our cosmic prison, but we can make it a home. Good night, fellow traveler. May your dreams be peaceful and your sleep be deep. May you wake refreshed and ready to face another day on this extraordinary planet, this rare and precious world, this only home we will ever have. The universe is vast and dark and silent, but you are not. You are small and bright and full of voice, and that, in the end, is what matters. Sleep well. The stars will still be there tomorrow, waiting for you to look up and wonder once again. They always will be. And so will we curious, dreaming, wondering humans, asking our questions into the darkness, finding our answers in each other, making meaning out of mystery, one gentle night at a time. The cosmos stretches on forever, in all directions, into depths we can never fathom. And here, on one small world, orbiting one ordinary star, in one unremarkable corner of one average galaxy, life has found a way to know that. Life has found a way to care. Life has found a way to ask what it all means, even when the universe offers no reply. That question, asked in the silence, is its own kind of answer. That reaching into the darkness is its own kind of arrival. That wondering in the face of the void is its own kind of contact. We have touched the stars after all, not with our hands or our spacecraft or our radio signals, but with our minds, with our imaginations, with our dreams. And perhaps that is enough. Perhaps that was always meant to be enough. Perhaps the universe gave us exactly what we needed, exactly what we could handle, exactly what would make us who we are. Small but aware, brief but brilliant, alone but not lonely. Not really. Not when we have each other. Not when we have this moment. Not when we have the capacity to look up at the infinite and feel somehow at home. This is the end of our journey tonight, but it is not really an end. It is a pause, a rest, a gentle stop along a road that stretches on forever. Tomorrow the questions will return. Tomorrow the wondering will resume. Tomorrow the great mystery of existence will beckon us forward, as it always has, as it always will. But for now, sleep, dream, rest. You have earned it, curious one. You have looked into the darkness and found light. You have contemplated infinity and found your own small warmth. You have asked the hardest questions and discovered that the asking itself is worthwhile. The stars will keep their secrets for a little while longer. Let them. You have done enough for one night. You have wandered beautifully. You have traveled far. Now close your eyes. Let go of the cosmos. Let go of the questions. Let go of everything except the gentle rhythm of your breathing and the soft darkness behind your eyes. You are home. You are safe. You are exactly where you need to be. Good night. And as you drift further into sleep, let us linger a moment longer on this strange and beautiful truth. We are storytellers, we humans. It is perhaps our most defining characteristic. Other animals communicate, yes. They signal danger and desire and location. But only we tell stories. Only we create narratives that explain where we came from and where we are going and what it all means. The story of cosmic loneliness is one of our newest stories. For most of human history, we did not know the stars were other suns. We did not know the galaxy existed. We did not know the universe had a beginning or would have an end. We lived in a smaller, simpler cosmos, surrounded by gods and spirits and magic. Now we live in a larger cosmos, a cosmos revealed by science, by careful observation, by the painstaking accumulation of evidence over centuries. This cosmos is stranger than our ancestors imagined, more beautiful and more terrible, more vast and more empty. But we are still storytellers. We still make sense of our situation through narrative. And the story of cosmic loneliness, the story I have been telling you tonight, is not the only story we can tell. There is another story, equally true, that runs alongside the first. It is the story of cosmic connection. The story of how we are made of the same stuff as everything else, how we participate in the same processes, how we belong to the same unfolding drama that has been playing out since the beginning of time. In this story, we are not lonely at all. We are woven into the fabric of reality so thoroughly that loneliness becomes meaningless. The stars are not distant strangers, but relatives, cousins in the great family of matter and energy. The empty spaces between the galaxies are not voids but connections, the same space-time that holds us here, holding everything else together. Which story is true? Both of them. Neither of them. They are lenses through which we view the same reality, emphasizing different aspects, illuminating different truths. The story of loneliness reminds us of the obstacles we face. The story of connection reminds us of the miracles we embody. Wisdom lies in holding both stories at once, in feeling the vastness and the intimacy, in knowing our limits and celebrating our achievements, in accepting what we cannot change and working to change what we can. This is what Brian Cox does, I think. He holds the darkness and the light together. He looks unflinchingly at the hardest truths while maintaining his sense of wonder. He does not pretend the universe is easier than it is, but he also does not pretend it is worse than it is. The universe is magnificent. That is the bottom line. Whatever else is true, whatever obstacles exist, whatever loneliness we must endure, the cosmos is breathtakingly, heartbreakingly, incomprehensibly magnificent, and we get to witness it for this brief moment with these imperfect senses. Through these fleeting lives, we get to be part of it. That is not a consolation prize. That is the prize. That is everything. So as you sink deeper into sleep, carry that with you. Not just the loneliness, but the magnificence. Not just the barriers, but the beauty. Not just what we cannot have, but what we already possess. The night sky is above you, even now, even if you cannot see it through walls and roofs and clouds. The stars are burning as they have burned for billions of years, as they will burn for billions more. The galaxies are spinning, slowly, majestically, in their eternal dance. The universe is doing what it has always done, expanding and evolving and producing against all odds pockets of order and complexity and life. And you are here, part of it all, temporary but real, small but significant, alone in one sense, connected in another. Let the two truths braid together in your mind. Let the loneliness and the connection become one feeling, one understanding, one gentle peace that settles over you like starlight, like moonlight, like the soft darkness of a night that has no end. You are a child of the cosmos. You are a miracle of matter become aware. You are the universe's way of experiencing itself, of asking questions, of seeking meaning. And that is enough, more than enough. It is everything. Now let the thoughts slow. Let the words fade. Let the vast picture shrink back down to this room, this bed, this body, this breath. In and out. In and out. The rhythm of life continuing, as it has continued for billions of years, as it will continue for some time yet. You are part of that rhythm. You are part of that continuity. You are part of something so much larger than yourself that the word part hardly seems adequate. But you are also you, individual, unique, the only configuration of atoms in the entire universe that is precisely, exactly you. That has never happened before and will never happen again. In all the vastness of space and time, there is only one you. Treasure that. Hold that knowledge close. In a cosmos of sameness and repetition, of hydrogen and helium and the same few laws playing out over and over, you are novel. You are original. You are a first draft with no revision coming. The stars will wait. The questions will wait. The great mystery of existence will be patient. For now, there is only sleep, only rest, only the gentle letting go that every conscious being needs. Enter that darkness gratefully. Tomorrow is another day, another chance, another opportunity to wonder and explore and love. But tonight, you are at peace. The universe can continue without your attention, as it has always done, as it always will. Sleep now. Sleep well. Good night.